I'm going to go through a few examples. So if you get a question on the test that says simplify and combine like terms. So I'm going to do, I think, about 5 different examples to show you what this means. So the first one is going to be something like this. A lot of times you're going to see the distributive property involved in these types of questions. So you need to be able to recognize the distributive property. If you don't know what that is or how to use it, watch that video on Facebook because I'm going to go through it quickly here. So 4 times this mathematical expression 2a plus 3 plus 7a. And so we need to simplify and combine like terms. So first we're going to use the distributive property. Again, if you don't know how to do that, please watch the video. So we go 4 times 2a, that's 8a. 4 times positive 3 is 12, plus 7a. And then what we're going to do is kind of put like terms together. And so here's an a and here's an a. So we're going to just first put them beside each other, and then we're going to combine them. Since we have this is addition, we can use the commutative property, and if you don't know what that is, watch the video. So we can move these around. So 8a plus 7a plus 12. These two expressions are equivalent. I've just changed these two terms, but we can do that with addition. So when we now have a's, this is when we're going to combine like terms. So anything with an a beside it, we can combine. And the way we do that is you just look at the number part of the a. So here's an 8 and here's a 7, and then you do the mathematical expression with those numbers. So 8 plus 7, so we're just going to go 8 plus 7, so that gives us 15. And a. So we didn't lose the a, we've just combined the terms. So 8a plus 7a is 15a. For example, if you think of this in words, 8 apples plus 7 apples gives us 15 apples. So that's all you're doing when you're combining like terms. So we're at 15a plus 12. And that would be the answer. We can't combine this any further because this has an a on it and this doesn't. So that we can't simplify this any further. This would be the answer to this question. We'll do another example. 7y minus 3 times 8y minus 2. So this is a little bit trickier. Again, you need to know the distributive property, and I'm not going to spend a lot of time doing it here. 7y, so we're going to do the distributive property, and again, this is a tricky one because there's a minus sign out here. So we have to go minus 3 times 8 is minus 24y. So when we're multiplying 3 times 8y, again, we just do the multiplication, but we keep the y. So here's one thing I forgot to mention. When you're multiplying numbers, they don't need to be the same, right? So this is 3 and this is 8y. So we can multiply unlike terms, and we just do the math. 3 times 8, and we get 24y. We cannot add or subtract numbers that do not have the same term. So we can multiply them, but we can't add and subtract them. So I'll get to that here. We're going to continue with the distributive property. Minus 3 times minus 2 is a positive 6. So now again, we have two things beside each other that are y and y, so we can combine these. So 7y minus 24y, and so again we just look at the numbers. So 7 minus 24, that's minus 17y. And we leave the plus 6. Now we can't combine this any further because this is an addition. So this is the answer to that question. Now we can flip these around because of the commutative property, so the answer might actually be written as 6 minus 17y. But that's as these two are the same thing, and we can't simplify this any further. We can't do anything with the 6 and the 17 because this has a y and this does not. One-eighth x plus 1/2. 12 minus x. 1/8x, we're going to use the distributive property. 1/2 times 12 is the same as 12 divided by 2 is 6. 1/2 times negative x is negative 1/2 x. So we're going to put like things together. 1/2 x minus 1/2, or 1/8 x minus 1/2 x plus 6. I just move that over here so they're close to each other. You don't have to do that. I mean, you can just look at it and do the math, but sometimes it makes it easier for people to see them when it's together. So again, even though these are fractions, we're just doing the same thing. We just look at the numerical part of it and do it. So 1/8 minus 1/2. You should be able to do that. If not, watch the video in fractions. 1/8 minus 1/2 goes to 1/8 minus 4/8 equals minus 3/8. So even though these are fractions, it is the same thing. We're combining like terms only when they have x's beside each other. We can't combine it any further if they don't have an x. And again, sometimes they might write it like this. Instead of negative 3/8 x plus 6, they may, because of the commutative property, we can flip those to say 6 minus 3/8 x. We're going to do two more problems that are a little bit more complicated. 4d plus 3 times 7 plus 2d plus 5d squared. So 4d, and we're going to use the distributive property. And remember, we can do multiplication on things even though this doesn't have a d. We can multiply it and we can divide it, but we cannot add or subtract it. We can only add or subtract if they have like terms. 3 times 7, 21. 3 times 2d is 6d. We're just taking 3 times 2 is 6 and keeping the d. 3 times 5d squared, we just again do the multiplication on the numbers. 3 times 5 is 15, and we just keep the d squared. We don't do anything with it, we just write it down again. We're going to put like terms together. Since here's a d and here's a d, we can combine these. So 4d plus 6d is 10d. We cannot simplify this any further. This is a d, this is a d squared. They're not the same thing, so you can't combine them. So this would be the answer to this problem. Now sometimes they like to write squared units in the front. So again, because of the commutative property, we can write these in any order we want to. These two things are the same, and so this would be the answer. Either one of these is the answer to this problem. But the key thing to remember is you can add things that have a d on them, but you can't add a d squared to a d. This is as simple as you're going to get that expression. We'll do one more. (3x plus 9xy plus 2y minus 3x squared minus 10xy plus 5x plus 4y squared plus 15 x squared. So the first thing we're going to do is put like terms close to each other, so because we have a lot of different types of terms here. So we'll just start at the beginning. We have 3x, and when you have a big long thing like this, once I've written it down, I like to cross it out so I know that I got it. So we wrote down the 3x. Look for any other x's. Well, that's xy. That's not the same as x. That's y. X squared. That's not the same as x. xy, x. Oh, here's a 5x. So I'm going to do plus 5x. So I've written that down. Y squared, x squared. Okay? So I have 3x plus 5x. Next term is 9xy. So now that I've written, I'm just rewriting this so that we can combine terms and it's easier to see. So I'm not doing any math, I'm just getting these terms next to each other. 9xy, no, oh, here's an xy. So minus 10xy, so we got that. No, okay. Next term is y, so plus 2y. So we got that. That's an x squared. That's a y squared. So that is not the same. And there's an x squared. So that's just by itself. Minus 3x squared. Again, just rewriting this to get things beside each other. So we've already gotten those. Y squared. Nope. 15x squared. Okay. So let's put that next to that one. So we've already written that down. Plus 4y squared. Okay, so we took our original expression and we've just rewritten it so that like terms are kind of next to each other so we can simplify it easier. It just makes it easier for us to do. Again, you probably want to cross them out as you rewrite them just so you know what you have and what you don't have, so you don't miss something or you don't double count something. So now let's combine like terms. Here we have 3x plus 5x. So we can combine these x's. 3x plus 5x is just 3 plus 5 is 8x. Plus, here we have 9xy minus 10xy. So even though there's 2 here, it's still, we can only combine, this is the same philosophy. So here we have 9 minus 10. So 9 minus 10 is negative 1. So this is really going to be minus 1xy. When we have a 1 in front of a variable, we generally don't write it. So how this would actually be written would be minus xy. We also generally don't write plus negative xy. We would just write 8x minus xy. So it was negative 1xy. It used to say plus negative 1xy, and then we wrote plus negative xy, and really a plus, a negative is just minus. So hopefully that makes sense. Then we have 2y. There's nothing to combine the 2y with because there's not another y in the whole expression. So that's it. Minus, here we have minus 3x squared plus 15x squared. So we can combine these two things. So we have minus 3 plus 15. So minus 3 plus 15 is 12. You can also think of it as 15 minus 3, right? Because of the commutative property, we can flip those around if it's easier to think that way. 15 minus 3 is 12. So this is a positive 12x squared. And then we have a plus 4y squared. So we have 8x minus xy plus 2y plus 12x squared plus 4yx squared. Or sorry, y squared. So there's no other x's, no other xy's, no other y's, no other x squareds, no other y squareds. So this is the simplest form that we can write this in. So that would be the answer to this problem.